Hello everyone. Today I'd like to discuss the golden idea of calculus using this example, and we're going to be working from the bottom up here. So let's say I have this guy named George, and he needs to get from point A to point B. For the sake of simplicity, we're going to say from 0 meters to 1 meter. And we're going to model where he goes using a function f. So we're going to say that at f of 0, he's at point A. Completely far away from point B, he's just about to start. Now, here's the thing. With every increase in an f of x function, he's going to go the distance, which is between him and point B, half of that. So sorry, let me reiterate. So from point A to point B, he's going to go half the distance. As we can see here. First step, he goes half the distance. And if you want to reiterate it again, he's going to go half the distance between here and here, which is here, 3/4 of the whole distance. Let's say he does that again. He's going to go half from here and here, and he's going to end up here, 7/8 the distance. One more time, he gets to right here, really, really close. And over here, I signified how far away he is from point A. So as you can see, f of 1, he's 0.5 meters away from point A. F of 2, 0.75 meters, so closer to B. F of 3, closer, really close by F of 4. He's 93.75% there to his destination. Now let's say you repeat this on and on and on, and you go all the way to 50 steps. Where will he be? You'll be extremely close. 0.9999999 yada 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 82. He's so close, so close. And let's say, you know what, let's go to 100. Well, I didn't write it here because I don't want to waste my time. He's going to get even closer, but he's not going to get exactly to 1. He's going to go like 0.9999 yada yada yada. So, what do we do here? We set a limit. If you don't know what a limit is, that's okay. I'll say what it is right now. We're going to say that f of x goes to infinity. This terminology right here means x approaches infinity. So think of it, he takes an infinite amount of steps, all the way from 0 to 1. And where will he end up? He's going to end up at point B, finally, after an infinite number of steps. So, obviously this isn't the case. If you want to go from point A to point B in real life, you just walk, right? So how come in this case, if you look at it this way, it will seem as if you will never get from one place to the other, using this half rule. Well, that's kind of the golden idea of calculus. Let me take out this piece of paper over here. Close this up. This is the golden idea. Performing some type of mathematical procedure an infinite number of times can lead to a finite answer. Try it yourself. Try walking from one side of your room to the other. I'm assuming you accomplished that task, but if you look at it in this perspective, you're technically never going to get there, right? Wrong. In calculus, doing something an infinite number of times can lead to a finite answer. Not an infinite answer, a finite answer. And so this is what we do when we find limits, or if you're going to learn later, derivatives and integrals. We're doing something an infinite number of times, so it gets infinitely smaller, infinitely large, depending on what we're trying to do. So this is really the golden idea of calculus. It does irk a lot of students the first time they see it. Infinity, that's a big number, right? We're going to be dealing with really difficult stuff, but that is not always the case. In some cases, you're just taking a normal example, George going from one side of his room, let's say, to the other side, but turning it into a calculus problem so you can actually see what's happening here. And that about wraps it up. If you have any other questions, please put something in the comments. I'll be glad to answer them. And yeah,